Hello, this is Professor Teresa Pelkie. This is Session 10, Part 2, Other Types of Joins. In this session, we'll look at some other types of joins that are used with SQL. To get started, let's review a simple inner join. Recall that this is the default type of join that is used when you specify just the join keyword as shown here. In this example, we are joining the student ID and name columns from the members table with the advisor title and name from the advisors table. The data is shown in order by the student name. The on condition is in the advisor ID, which is the same column name in both tables. When you use an inner join, you get data in the result set when there is a match between the tables. So what we get is a list of all students that have an advisor. We see the student ID, student name, and advisor name. Now let's change the join from the default inner join to a left join. The only thing that is different on this slide compared with the previous slide is that I've added the keyword left on line 6, so I now have a left join. When you use a left join, you get all of the rows from the left table, in this case the members table, whether or not they have a corresponding row in the right table. In this example, the right table is the advisors table. So the end result is we see all of the students, whether or not they have an advisor. Now we have a completely different type of join. On line 6, the join is specified as a right join. You can see the results starting at the first row of the result grid. We see that Dr. Drake has not been assigned as the advisor for any students. So the right join takes all of the data in the right table, which in this select is the advisors table. It lists all of the data in the advisors table, whether or not there is a match with data in the members table. Now this might look a bit odd since we're not used to looking at a result grid where the data in the left side is shown as null. You'll see on the next slide how we can flip things around in the select statement to make it look like you would expect. Look first at the result grid on this slide. The first column is the advisor name. You can see that it shows the advisors whether or not they have been assigned any students. Dr. Drake is the first advisor listed, and he does not have any students assigned to him. Now look at the statement, especially at the join type. You see that this is a left join. Several slides back, you saw a different left join. The difference is the order in which the tables were specified. In the previous left join, the from table was members and the left join table was advisors. On this slide, the from table is advisors and the left join table is members. Recall that with a left join, you'll get all of the rows in the left table. In this case, the advisors table. If there is matching data in the right table, the members table, you get that data. If there is no match, you get nulls. This slide shows the left join on the left side of the slide and the equivalent right join on the right side of the slide. If you look at the result grids, you can see that the data in the grids is the same, it is just in a different column order. On the left side, the advisor name appears first, so you always see data in the left column of the result grid. On the right side, the student ID and name appears first, so you see the null values appear first when you have the advisor who does not have any students assigned. Keep in mind, as far as SQL is concerned, these two result grids are the same. It really doesn't matter to SQL which order the columns in the result grid are displayed. Now, it may or may not make a difference to you which order the columns are displayed. If you will be creating an SQL statement for an end user, for example, to import data into an Excel workbook, they might find it easier to understand the data if it looks like the left side of this slide. The result grid on the left emphasizes the advisor names, not the student IDs and names. If you are writing an SQL statement that will only be used in an application, the application itself will pick out the column values that it needs from the results set in the order needed by the application. For example, if you will be displaying this data on a PHP web page, you can use the PHP code to put the data into the order you want it displayed on the web page. So based on what you're seeing here, you can get the same results for a right join by using a left join. Note that you do need to set the orders of the tables correctly. It is not just a matter of substituting the keyword left for right, but you may find that you don't need to code right join statements. If you use tools to generate SQL, you might find that the tool will generate right joins, so you need to be aware of this type of join. But in most cases, you can easily recode the select statement to be a left join and get the same results as a right join. To finish up our discussion of joins for now, we'll look at a very unusual type of join that has a few specialized uses. This type of join is called a cross join. Technically, it's considered to be the multiplication of all items in one set with all items in another set. This is referred to as a Cartesian product, named after René Descartes. In addition to thinking up mathematical theories, Descartes is probably most famous for his musing, cogito ergo sum, or I think therefore I am. That statement causes endless hours of discussion in Intro to Philosophy courses. So if you are interested in pursuing that, you can look into those courses. So let's take a look at what a cross join is and what it produces. We're using the advisors and members table again. This time, the from table is advisors and it is cross-joined to the members table. Everything is put in order by the member name. What you get in the results set is a list of all of the advisors joined to all of the students. This slide shows two sets. There are many more in the actual results set. You can think of this as being a set of all the advisors joined with each individual student, looking at it from the left column to the right. Or you can think of this as being a set of each student with all of the advisors listed, looking at it from the right to the left. As is, this result set does not seem to be that useful. It's just everybody joined to everybody else. We'll refine the cross join. Let's say you wanted to produce a list of all advisors and all students with some conditions. The first condition is the student has not been assigned to an advisor. The second condition is that the advisor currently is assigned to 4 or less students. The idea is the administrator who is in charge of assigning advisors to students wants this list so that she can quickly go through the list and assign these students to an advisor. By putting all of the data in the same list, it will be easy to just go down through the list and select an advisor for each student. So what we're seeing here is what the result set will look like when we are done refining the cross join. We'll apply the two conditions to the cross join to limit the data that is included in the result set. The first refinement is easy. To get just the members that do not have an advisor, we'll add the where clause that is shown here. In this where clause, we are testing for the member advisor ID value is null. Note that you do not test for equal to null. Since there is no value for null, it cannot be equal to anything. That's kind of a picky little SQL syntax issue, but that is the way it is. You test for is null or is not null. The only end result of this cross join is that we are now getting only members in the result set that do not have an advisor assigned to them. We'll now solve the next part of the refinement. We also want to limit the advisors to just those who are currently assigned to 4 or fewer students. Rather than just add the code into the cross-join statement, let's look at how to develop a complex select statement by building it up one step at a time. This process is sometimes called stepwise refinement, and you can use this with any programming task when you need to try something out before putting it all together into one big statement. The immediate task that needs to be solved is this. We need to be able to figure out how to get the advisor IDs for those advisors who are assigned to 4 or fewer students. So this select statement gives us the results set shown here. We have the list of advisor ID values from the advisor table, and the count of the number of students the advisor is assigned to. Note that we have to use a left join for this statement. If we use just a join, the result set would not include advisor ID 8, since that advisor does not have any assignments. Part of the reason why I am developing this part of the cross join first, independently of the main statement, is so that I can check to see if I am getting realistic count values. In this case, I can easily see that I have an advisor who does not have any assignments. If I did not run this statement first and check the results, it would be very easy to make a mistake and just specify the join as join and not left join. Keep in mind when you use join, you only get rows where there is a match between the two tables. So if I used join by mistake and did not have a way to review the counts, I might have missed advisor 8 who has no assignments. Let's make one final refinement to the code that will count the number of assignments for an advisor. In this select, I've added the having clause to compare the count of the assignments to determine if there are 4 or fewer. Keep in mind, the having condition is applied after the group by is performed. The group by creates the subsets within the data, and the having is applied to each of the subsets. So what I end up with is a result set that shows just the advisor ID values for the advisors who have 4 or fewer members assigned to them. At this point, I have created and tested a select statement that I can incorporate into the cross join. When I take this into the cross join, I'll drop the count from the column list since I don't need the actual count. I just need the ID for the advisors. And here's the final cross join. I've taken the select statement that I developed on the previous slides to count the number of assignments and brought that into the where clause of this statement. The where clause is a compound clause with an and conjunction. I am including rows in the cross join where the member's advisor ID is null and where the advisor ID in the advisor table is in the result set produced by the embedded select statement. The result set shows that I now have a repeating group of advisors and the students that need an advisor. I can arrange to print out this result set or export it to a format that can be used in another program like Excel and give it to the administrator who will make the assignments. Because all the data is in one place, it will be easy for the person who has to work with this to go through and assign an advisor to a student. Like most other requirements in SQL, there are probably many other ways that you could do this. It is somewhat of a contrived example to see how we can make use of a cross join. In the next session, we will start working with views. A view is a way to encapsulate a select statement so that it becomes part of a schema.